What if in the stillness of the universe, something from far beyond our own star system quietly entered our solar system, a visitor, unexpected and unnoticed by the bustling world below? It wouldn't announce itself with a grand spectacle or some dramatic arrival. No, it would slip by, unnoticed by most, yet still making its mark as it drifts through the vast emptiness of space. This is the story of 3IATLAS, the first interstellar object discovered passing through our solar system, an object that raised as many questions as it answered. In 2017, humanity made a discovery that would forever change our understanding of space. We spotted a strange object speeding through our solar system, and to our surprise, it wasn't from within our solar system at all. 3IATLAS, as it came to be known, was the first interstellar object to be identified as coming from another star system. It wasn't a comet or asteroid in the usual sense. It was unlike anything astronomers had ever seen before. Its trajectory and speed were perplexing. It didn't follow the typical patterns of bodies bound by the sun's gravity. Instead, it seemed to be moving at an almost unnatural velocity, speeding through our solar system without being pulled in by the sun or any of the planets. This sudden appearance from the vast unknown raised a quiet but profound question. What if this wasn't just a fluke, a chance encounter with our solar system? What if it had come here for a reason? We often think of objects in space as moving according to the predictable laws of physics, and in many ways, that's true. But when something so unexpected enters the scene, we are forced to reconsider. What if 3IATLAS wasn't merely a random piece of space debris, a fragment from a distant star system? What if, instead, it was part of something bigger, a purposeful journey, an object sent on a mission, traveling across unimaginable distances to reach us? What if, for reasons we cannot yet understand, this object had come here to observe us, to study the inner workings of our solar system, perhaps even to study us? It's easy to think of the universe as vast and empty, a place where objects simply drift along in an endless journey, without meaning or intention. But there's a quiet possibility that we might be missing something fundamental. Imagine, just for a moment, that 3IATLAS wasn't just a rock or a comet on a random trajectory. What if it was something more, something designed, something with intelligence behind its path? Could this object be the first sign of an intelligent force from another star system? Could it be a message, a probe, or a sign from an advanced civilization, traveling across time and space, silently studying the very system we inhabit? These questions are unsettling, not because they have answers, but because they don't. The reality of 3IATLAS is that it forces us to confront the unknown in ways we aren't prepared for. We often think we understand the laws of nature, the mechanics of space, the predictable dance of celestial bodies, but here comes 3IATLAS, a silent intruder, challenging our understanding of what's possible in the universe. Its presence is a reminder of how little we truly know. Could this be the first of many interstellar objects that slip through unnoticed? Or perhaps it was always meant to be the one we saw, the one that would open our eyes to the vastness of space and the possibilities it holds. Yet, we must also acknowledge the possibility that 3IATLAS is nothing more than a naturally occurring object, a piece of space debris following its path through the cosmos without any higher purpose. Perhaps it is simply the result of gravitational forces and the natural mechanics of celestial motion. After all, many scientists have suggested that the object's path could simply be the result of gravity's influence and the peculiarities of its interstellar journey. The object might just be a fragment from a distant star system, flung into our solar system as part of the cosmic ebb and flow. But even in this interpretation, there is something profound to consider. The fact that an object from another star system could wander so far from its home and end up here, in our solar system, is a testament to the incredible scale of the universe. Space is not the empty void we sometimes imagine it to be. It is filled with objects, with stories, with histories stretching across time and space. And yet, despite this vastness, we rarely encounter anything from beyond our solar system. And then, one day, we do. This arrival of 3IATLAS is a humbling reminder of just how much of the universe remains out of our reach, waiting for us to understand it. In the quiet moments, as we look up at the night sky, it's easy to forget how much is out there, hidden from our view. We may look to the stars and see nothing but distant pinpricks of light, each one a distant world, a potential home for life. But perhaps we're looking in the wrong places. What if the universe is quietly sending us messages, not in words or signals, but in objects, in strange phenomena that slip unnoticed through our sky? What if, in the case of 3IATLAS, the object was never meant to be observed at all, but simply arrived, part of an ongoing story we are just beginning to understand? As we reflect on 3IATLAS's passing, we are left with more questions than answers. Was it just an object passing by? Or was it part of something greater? Part of a plan or message we don't yet comprehend? This is the heart of the mystery. The more we learn, the less certain we become. There are no easy answers, no comforting conclusions. There is only the quiet recognition that the universe is vast, and in its vastness, we are but small travelers on a journey we don't yet fully understand. What if 3IATLAS wasn't just a passerby, but a message? What if its presence means something more than we can yet grasp? As we continue to wonder about the nature of this interstellar visitor, it becomes clear there's so much more to discover, so much more we have yet to understand. Perhaps, in time, the answers will reveal themselves. But for now, we are left to ponder the possibilities, to dream of what might lie beyond the stars. What if the object that we observed in our solar system was not just a random, fleeting visitor, but a remnant from a far-off star system, traveling across light years of space to reach us? To truly understand the origins of 3IATLAS, we need to step back and consider the vast processes of the universe that give birth to such objects, and how they might end up in our neighborhood, arriving silently and unexpectedly. The universe is a place of constant motion and change, with stars, planets, and other celestial objects constantly shifting, evolving, and interacting. Our own star, the Sun, was born around 6 billion years ago from a massive cloud of gas and dust that collapsed under gravity. Over time, this material formed planets, moons, and other bodies, many of which are still orbiting the Sun today. But the Sun, like all stars, will eventually die, and its remnants will scatter across the universe. Some of these remnants will form new stars, planets, or even objects like asteroids and comets. These objects will continue to travel through space, drifting through galaxies and star systems until they encounter something else, a gravitational force, a collision, or perhaps the influence of an even more distant star system. This is where objects like 3IATLAS come in. It is thought that this object, which we now know as 3IATLAS, is an interstellar object, meaning it comes from outside our solar system, from another star system entirely. It is likely that 3IATLAS was once part of a different star system, perhaps even a planetesimal or a piece of a shattered planet that was flung out into the depths of space. This journey, which could have spanned millions or even billions of years, is the result of forces far beyond our control. One of the most intriguing aspects of 3IATLAS's journey is the question of how it could have been ejected from its original star system. There are many possibilities. One of the most likely scenarios is that it was cast out due to the gravitational interactions of other bodies in its home system. Stars, especially those in densely packed star clusters, interact with each other's gravity in such a way that objects can be gravitationally flung out of their orbits. This process is called gravitational ejection, and it is one of the primary ways that objects like comets and asteroids are sent hurtling through space. It is also possible that 3IATLAS was the result of a violent event in its original system, such as the destruction of a planet or a collision between two massive bodies. These types of cataclysmic events are not uncommon in the universe, and they can send debris flying across vast distances, eventually reaching other star systems. But what if 3IATLAS wasn't just a random object flung through space by a violent event? What if it was part of a larger cosmic cycle, one that took it on a journey through multiple star systems? Some scientists speculate that objects like 3IATLAS may be part of a natural long-term cycle of cosmic motion, drifting from one star system to another over the course of millions or even billions of years. This would suggest that there are many more objects like 3IATLAS out there, traveling between the stars, silently observing the universe as they pass through. The possibility that 3IATLAS is part of a larger cycle is both fascinating and humbling. If this object has been traveling for billions of years, drifting between stars and star systems, then we are truly witnessing only a brief moment in its long and complex journey. It's a reminder that, in the grand scheme of things, our solar system is just one small stop on a much larger cosmic map. Yet, despite the vastness of the universe and the incredible distance that 3IATLAS traveled, its passage through our solar system was not entirely random. The object's trajectory and velocity suggest that it was not simply drifting through space, but was instead influenced by the gravitational pull of the Sun and the other planets in our system. While the object's path may have been set by the forces of gravity, it is possible that something else guided its motion. Could it be that 3IATLAS was not just a random fragment of space debris, but a carefully planned journey, one that was guided by an intelligence far beyond our own? As we consider the possibility of 3IATLAS being part of a deliberate journey, we begin to venture into the realm of speculation. Could this object, which has traveled across the vast emptiness of space, be more than just an asteroid or comet? Could it be a probe sent from a distant star system, designed to study our solar system and its planets? Perhaps 3IATLAS is not just a random visitor, but a message, a signal from an alien civilization, traveling across the stars to reach us. The idea that 3IATLAS could be something more than a simple rock is intriguing, but it remains just that, an idea. There is no concrete evidence to support this notion, but the possibility of its being something more than what we can see is enough to make us pause and wonder. Yet, even if 3IATLAS is simply a natural object, it serves as a powerful reminder of the complexity and beauty of the universe. The fact that such an object could travel so far and reach our solar system is a testament to the forces of nature that govern the cosmos. It's a reminder that the universe is full of mysteries, many of which we may never fully understand. In the end, whether 3IATLAS is a simple piece of cosmic debris or something more profound, its arrival is a glimpse into the vastness of space, a reminder of how much we have yet to learn about the universe. As we contemplate the journey of 3IATLAS, we are reminded of how little we truly know about the universe and our place within it. The object may have come from a far-off star system, or it may have been part of a natural cycle of cosmic motion. Either way, its passage through our solar system raises more questions than answers, inviting us to look deeper into the mysteries of space. What if there are more objects like 3IATLAS out there, drifting through the cosmos, waiting for us to find them? And what if, in the future, we will learn that this object was only the beginning of something far more significant? The journey of 3IATLAS is not just a story about a single object passing through our solar system. It's a story about the universe itself, a universe filled with objects, forces, and mysteries that are beyond our comprehension. As we look to the stars, we are reminded that we are just one small part of a much larger cosmic story, one that is still unfolding, one that we may never fully understand, but perhaps that is what makes it so beautiful. What if the path of 3IATLAS was more than just an erratic trajectory, more than a random passage through the solar system? What if it was a carefully calculated route, an intentional journey through the heart of our cosmic neighborhood, guided by forces we do not yet understand? When 3IATLAS was first detected by astronomers in 2017, it immediately captured the scientific community's attention due to its unusual characteristics. Unlike comets or asteroids that typically orbit the Sun in more predictable elliptical paths, 3IATLAS traveled at a velocity that was significantly faster than any object in our solar system. Its trajectory was also different, more hyperbolic, as if it was simply passing through rather than being bound by the Sun's gravity. This raised the possibility that it came from a far-off star system, as the object appeared to be moving at a speed that was too high for the Sun to capture. In short, it was on its way out of our solar system almost as quickly as it had entered. But what if this path was not just a consequence of gravitational physics, but something more? Could it have been set by some guiding force, some intelligence from another star system, with the purpose of arriving at this precise moment, in this exact location? What if the object had been on this journey for eons, deliberately steering through space, moving in such a way that its passage through our solar system would serve some unknown purpose? The exact nature of 3IATLAS's path provides some tantalizing clues. Initially, scientists noticed that the object was moving too quickly to be bound by the Sun's gravity, indicating that it would not remain in our solar system. Most comets and asteroids travel in elliptical orbits, looping back toward the Sun at regular intervals. But 3IATLAS Atlas was different. Its trajectory suggested that it was just passing through, not intending to stay. The hyperbolic orbit indicated it had come from deep space, traveling across vast interstellar distances, a wanderer in the cosmic sea, moving through our solar system only briefly before continuing on its journey. Yet, despite its rapid exit, 3IATLAS did not follow the trajectory that we might expect from a random object passing through our solar system. Its path was distinctly different from the paths of most objects in our solar system, suggesting that something, whether natural or artificial, had influenced its motion, while it could have simply been ejected from its original system due to some gravitational interaction. Its velocity and trajectory were unlike anything we've observed from typical asteroids or comets. It's possible that 3IATLAS's path was influenced by the gravitational pull of the Sun and the planets, which altered its course slightly as it passed through. This gravitational bending of the path is something that happens to all objects passing near a large mass, like the Sunday. But what if the bending of its path was not just a consequence of gravity? What if there was an external force, a design, at work, guiding the object on its way? Could 3IATLAS have been deliberately directed to pass through the solar system in a way that would allow it to interact with our planet, or even observe our Sun and its planets? What if its passing was not random at all, but part of some larger, unknown cosmic plan? One of the most intriguing aspects of 3IATLAS's trajectory is its interaction with the Sunday. As it passed through the solar system, it did not appear to be significantly influenced by the Sun's gravity, as many expected. It was moving too fast for the Sun to capture it, but it did not slow down in the way that a comet or asteroid might. This raises an interesting possibility. What if 3IATLAS was not influenced by the Sun's gravity in the way we expected, because it was moving in a trajectory that had been deliberately calculated to avoid capture, perhaps in order to observe the solar system without drawing attention to itself? As we consider the path of 3IATLAS, we are reminded that our understanding of gravity, motion, and trajectories is still far from complete. The universe is vast and mysterious, and even the laws of physics we hold so dearly may not be as predictable as we think. The object's unusual velocity and path force us to reconsider the way we think about celestial motion and our place within the cosmos. But perhaps the most profound question raised by 3IATLAS's path is this: could we be the ones who are being observed? What if the object's path was not an accident, but a deliberate observation of our solar system? Imagine, for a moment, that this object wasn't just passing through for the sake of it, but that it was purposefully studying our planets, our Sun, our very existence. Could we be the subjects of a cosmic experiment, watched from afar by a force beyond our understanding? As we contemplate the path of 3IATLAS, it becomes clear that this is not just a simple story about an object passing through our solar system. It is a reminder of how little we know about the forces at play in the universe. The object's velocity, its trajectory, and its apparent interaction with the Sun all suggest that there is more to this story than meets the eye. Could we be looking at a deeper, more profound mystery, a cosmic riddle that we are only beginning to understand? The questions raised by 3IATLAS's path are not easy to answer, and perhaps we will never fully understand the forces that guided it. But what we do know is this: the universe is far more complex than we could have imagined, and objects like 3IATLAS are reminders of how little we know about the vastness of space and the possibilities that lie beyond our reach. What if 3IATLAS is not just a rock or fragment from a far-off star system, but something more, an ancient probe, a silent witness to the vast history of the universe? What if its journey through our solar system was not accidental, but part of a grander design, an intelligence-driven mission sent across light years of space to explore, to learn, and perhaps to return with information? When we consider the possibility that 3IATLAS might be more than a natural object, the notion of it being an ancient probe becomes compelling. A probe, or more specifically, a relic of an ancient civilization sent from a distant star system, could explain many of the peculiarities we observed in the object's journey. It wasn't just an erratic fragment of space debris. Its path, velocity, and shape all seemed so unusual and purpose-driven that it forces us to ask, could this be the work of an intelligence far more advanced than our own? In our search for extraterrestrial intelligence, SETI, We have long speculated about the possibility of alien civilizations sending out probes to explore the cosmos. We imagine vast fleets of spacecraft traveling between star systems, gathering data, discovering new worlds, and perhaps even leaving behind traces of their visits for us to find. But what if 3IATLAS is the first such clue? A fragment of a long-lost mission that has traveled for eons, silently observing the universe before it was finally noticed by our astronomers. What if this interstellar object is a probe, designed and sent by an advanced civilization, carrying with it valuable information, technologies, or knowledge that we are yet to understand? The idea of a cosmic probe is not a new one. Some scientists have speculated that intelligent civilizations, in their desire to explore the cosmos, might send out self-replicating probes to gather data, potentially sending them far beyond their home star system. These probes would be capable of traveling vast distances, observing, learning, and perhaps even transmitting information back to their creators. In the case of 3IATLAS, this probe might have been sent not just to explore our solar system, but to gather information, to study life, and to examine the conditions that exist on our planet. But how could such a probe survive across such an immense distance, especially when it would have to endure the ravages of time, radiation, and the dangers of space? The key to this idea lies in the possibility of advanced technology, something so far beyond our current capabilities that it seems almost impossible. We might imagine a probe that is self-sustaining, one that doesn't need to be guided by intelligent beings, but instead operates autonomously, running on energy sources that can withstand the harsh environment of space. Perhaps the technology behind 3IATLAS is ancient, much older than our own, and designed with resilience in mind, capable of surviving the vast emptiness of space for millennia. It's worth considering that this probe could have been designed in such a way that it wouldn't be noticed by us until it passed through our solar system. Its velocity, trajectory, and the fact that it's not bound to our sun could be part of its design, ensuring that it simply observes and records without interfering with the workings of the solar system. Perhaps it was never meant to land, never meant to make contact with Earth, but simply to pass through, gathering data on the planets, the sun, and the conditions of our solar system. But what could be the purpose of such a mission? Could it be that 3IATLAS was meant to study the biology of life on Earth, to observe how we, as a young civilization, interact with our environment, or to investigate the viability of our planet for future colonization? Or perhaps it was meant to analyze the sun itself, to understand the dynamics of our star and how it powers the solar system. The possibilities are vast, and the more we think about it, the more intriguing the idea becomes. The concept of 3IATLAS as an ancient probe also raises important questions about the nature of extraterrestrial life. Could it be that civilizations beyond our own have already explored the stars, leaving behind traces of their visits, like 3IATLAS, as silent witnesses to their passage? If so, what would it mean for us to discover such a relic? What does it say about the potential for life elsewhere in the universe? And how far can we go in our search for signs of intelligence beyond Earth? This idea opens up a world of speculation, where the line between science and science fiction blurs. What if we are not the first intelligent civilization to explore the stars? What if, like 3IATLAS, there are other objects from other civilizations, quietly passing through the void, gathering information, perhaps even preparing for a return? Could this object be a beacon, a message left by an ancient civilization, a reminder that we are not alone in the universe? Of course, this remains a speculative idea, and one that, at this point, has no solid evidence to support it. We don't yet know the true origin of 3IATLAS, and it could very well be a natural object, a fragment of an ancient star system that was simply ejected and ended up passing through our solar system. But the idea that it could be a probe sent by a distant intelligence to study the cosmos remains an intriguing possibility that forces us to think more deeply about the nature of exploration, both for ourselves and for the civilizations that may have come before us. As we continue to study 3IATLAS and other interstellar objects, we are left with more questions than answers. Is it truly a probe? Is it part of a larger mission? One that we don't yet understand. The uncertainty is both humbling and inspiring, urging us to continue exploring, to continue searching the stars for signs of life, of intelligence, and of the mysteries that lie beyond our reach. Perhaps, in time, we will learn more about 3IATLAS, and perhaps we will discover that it is not just an object, but a part of something much larger. A clue in a cosmic puzzle that spans across light years, a relic of an ancient civilization, quietly observing, silently waiting for us to unlock its secrets. What if 3IATLAS's behavior in our solar system wasn't just random, but a subtle reflection of intelligence, one that operates on a scale far beyond our comprehension? When it passed through our cosmic neighborhood, it did so in a manner that defied many of the expectations we have about how objects should behave. Its speed, trajectory, and motion were all unusual, sparking more curiosity about its true nature. What if this wasn't just the result of natural forces acting on an object, but a deliberate series of actions with a purpose behind them? As 3IATLAS approached our solar system, astronomers noticed several peculiarities about its behavior. One of the most significant aspects of its passage was its velocity. The object was moving at an extraordinary speed, far faster than most asteroids and comets that we observe within our solar system. Its speed was so great that it was not bound to our sun, meaning it would not stay in the solar system, but would continue on its journey out into the depths of space. This high velocity is not necessarily unusual for objects coming from other star systems, but it raised questions about what forces might be at work. Could it have been moving with purpose, directed by something beyond the typical gravitational forces we are familiar with? Another interesting aspect of its passage was its trajectory. 3IATLAS did not follow the typical elliptical orbits that comets or asteroids from our solar system generally follow. Instead, it was on a hyperbolic trajectory, a path that suggested it was passing through our solar system on its way to somewhere else. This is in stark contrast to most comets, which loop around the sun and eventually return to the outer reaches of the solar system. The hyperbolic trajectory of 3IATLAS suggested that it was simply passing through, as though it had no intention of staying. This is not the behavior we expect from most objects in our solar system, and it made 3IATLAS stand out from the rest of the cosmic debris that orbits our Sunday. However, it's not just the object's speed and trajectory that made it unique. 3IATLAS's interaction with the sun was another key area of intrigue. Typically, objects like comets or asteroids that come into close proximity to the sun experience a shift in their motion. The sun's gravity affects their trajectory, pulling them in and altering their paths. But with 3IATLAS, things were different. It seemed to move almost unaffected by the sun's gravitational pull. Some scientists have suggested that this could be explained by its high speed, but there are also other explanations to consider. Could 3IATLAS's motion have been influenced by an external force, something beyond our understanding? Or could it have been moving in such a way that the sun's gravity wasn't able to affect it the way it would most objects? There's also the question of the object's rotation. As 3IATLAS moved through the solar system, scientists observed that it was spinning, albeit very slowly. This rotation, combined with its unusual motion, suggested that the object might not be as simple as a mere rock or comet. Could the rotation be intentional? Could the object have been engineered to spin in a way that would allow it to gather data, adjust its course, or even communicate with whatever intelligence sent it here? While this idea might seem far-fetched, it does raise the intriguing possibility that 3IATLAS's behavior wasn't merely the result of natural forces, but was in some way controlled, guided by forces we cannot yet comprehend. As we reflect on the behavior of 3IATLAS, we are faced with the question, what if it's more than just a passing object? What if its path through our solar system is a carefully orchestrated maneuver? It's not beyond the realm of possibility that the object's behavior could have been part of a much larger plan, perhaps one that we do not yet fully understand. While the object may seem like a random visitor from deep space, its unusual motion suggests there is more to its journey than meets the eye. What if 3IATLAS was designed not just to pass through, but to gather information about our solar system, to observe our sun, planets, and possibly even Earth? This raises a fascinating question. Could this object have been engineered to study our world, to learn more about the conditions in our solar system, or even to monitor life on Earth? Could it have been sent on a mission to collect data, to send back information about the state of our solar system, or even to find out what life is like on our planet? If this is the case, then 3IATLAS might not be a random object at all, but a probe sent from a distant intelligence, part of a larger strategy to observe and study our solar system without directly interacting with it. It is also possible that the object's peculiar behavior is a result of the physics of interstellar travel, which we have yet to fully grasp. Perhaps the high velocity of 3I/ATLAS allowed it to bypass the gravitational pull of the Sun, and its hyperbolic trajectory was simply a natural result of its immense speed. If that is the case, then the object's motion would be a product of natural forces rather than intelligence. However, given the object's unusual characteristics, it is hard to rule out the possibility that something more is at play here, something that we don't yet understand. The behavior of 3I/ATLAS challenges our assumptions about the way objects in space should behave. We have long relied on our understanding of gravity, motion, and trajectory to predict the paths of objects in the solar system. But 3I/ATLAS has proven that there are still mysteries out there, objects that move in ways we don't fully comprehend. This makes it all the more intriguing, as it forces us to think beyond the limits of our current understanding. As we continue to study 3I/ATLAS, we are left with more questions than answers. Its high velocity, unusual trajectory, and strange behavior in the solar system suggest that there is more to this object than we can explain. Whether it is a natural object or the product of intelligence, 3I/ATLAS remains a profound reminder of the mysteries that lie beyond our understanding. Perhaps, as we continue to explore the cosmos, we will encounter more objects like 3I/ATLAS, silent visitors from far-off places, passing through our solar system, gathering information, and leaving us with more questions to ponder. What if 3I/ATLAS wasn't just a traveler, moving through our solar system with no particular aim or destination? What if it was something more, something that came to study, observe, or even watch us? What if, as it passed through our solar system, 3I/ATLAS was silently gathering data on the Sun, the planets, or even on Earth itself? Could we be the subjects of a cosmic experiment, watched by an intelligence far beyond our comprehension? As 3I/ATLAS sped through our solar system, astronomers and scientists watched with fascination. Its path, velocity, and behavior suggested that it was not just a random object passing through. There was something deliberate about its motion, something that suggested it was more than just an errant fragment of space debris. It was as if 3I/ATLAS had been guided through our solar system, purposefully studying the various celestial bodies in its path. But what was it looking for? Imagine, for a moment, that 3I/ATLAS wasn't simply a passing asteroid or comet, but a kind of cosmic probe sent by an alien civilization to gather information about our solar system. The fact that it arrived from another star system makes this scenario particularly intriguing. It suggests that the object might have been traveling across the vast emptiness of space for millions, even billions, of years, potentially sent on a mission of exploration. But why? What could such an advanced civilization want to know about our solar system? One possible answer is that 3I/ATLAS was sent to study our Sunday. The Sun is the life-giving force of our solar system, and understanding its behavior, its energy output, and its long-term stability is crucial for any civilization trying to survive and thrive in space. Perhaps 3I/ATLAS was sent to gather data on the Sun's activity, its radiation, its solar wind, and its interactions with the rest of the solar system. The Sun's behavior is a critical factor in the habitability of the planets around it, including Earth. If this object was indeed a probe, it could have been observing the Sun's activity and gathering information that might be of great interest to a distant civilization. But 3I/ATLAS could have been studying more than just the Sunday. It could have been observing the planets in our solar system, analyzing the conditions on Earth, and searching for signs of life. What if this object was designed to detect the chemical signatures of life, or to look for any indications of intelligent civilization? The presence of water on Earth, the complex chemical makeup of our atmosphere, and the patterns of life on our planet might have been of great interest to any extraterrestrial intelligence. Could 3I/ATLAS have been sent to study the development of life on Earth, to observe how life forms evolve and adapt to their environment? And what about us, humans? Could 3I/ATLAS have been sent to observe us, to learn more about our species and our place in the universe? After all, our planet is home to a growing civilization, one that is beginning to reach beyond its own atmosphere and explore the possibilities of space travel. What if the object was monitoring our technological advancements, tracking our progress, or even learning from our successes and mistakes. We are at a pivotal moment in our history, and it's possible that 3IATLAS was simply here to witness that moment, to collect data on a developing civilization that might one day become part of a much larger galactic community. The idea of 3IATLAS being a silent observer raises profound questions about the nature of intelligence, both human and extraterrestrial. If this object was indeed sent to study our solar system, it implies that there are other beings out there who are far more advanced than we are, capable of sending probes across vast distances of space, gathering data without ever needing to make direct contact. The idea that we might be the subjects of such an observation is both humbling and awe-inspiring. It suggests that we are not alone in the universe, and that our actions, our planet, and even our civilization are being watched by beings from beyond the stars. But there's another, more unsettling possibility. What if 3IATLAS wasn't just observing us in the sense of gathering scientific data, but was actually watching us as part of a much larger cosmic experiment? What if the object was part of a strategy to study the behavior of life on Earth, to observe how we react to new discoveries, how we interact with our environment, and how we respond to the unknown? Could it be that 3IATLAS was not just gathering data for the sake of knowledge, but as part of a larger plan to understand the dynamics of intelligent life, to monitor our progress, or even to test our response to contact with the unknown? This idea may seem like science fiction, but it speaks to a deep and existential question. Are we alone in the universe? Or is it possible that there are other civilizations out there, quietly watching and studying us, gathering information on our behavior, and perhaps even guiding our development without our knowledge? The notion that 3IATLAS could be a part of such a cosmic experiment forces us to reconsider our place in the universe. We may think of ourselves as the dominant intelligence in the solar system, but what if there are others out there, watching us, shaping our destiny in ways we cannot yet understand? As we reflect on the passage of 3IATLAS, we are reminded of how little we truly know about the universe. The object's behavior and trajectory suggest that there is much more to this story than we can currently explain. Whether it was sent to study the sun, the planets, or even us, 3IATLAS forces us to confront the reality that we may not be the only intelligent beings in the cosmos. It reminds us that, despite our technological advancements, we are still only beginning to scratch the surface of understanding the vast and mysterious universe we live in. In the end, the question remains: what was 3IATLAS looking for? Was it simply passing through? Or was it here for a more profound purpose? Perhaps we may never know the full extent of its mission, but what we do know is this: its passage through our solar system has opened up a world of possibilities, forcing us to reconsider our place in the cosmos and to look outward with greater curiosity and wonder. What if 3IATLAS was not just a simple object traveling across space, but a sophisticated creation, a messenger or tool sent by a hidden intelligence from a faraway star system? What if its arrival in our solar system was not a chance encounter, but part of a deliberate design, one that is beyond our current understanding of technology and purpose? This idea may seem like science fiction, but it is a question worth contemplating as we begin to explore the possibility that we may not be as alone in the universe as we once thought. When 3IATLAS was first detected in 2017, it was hailed as an extraordinary discovery. It was the first known interstellar object to pass through our solar system. Its trajectory, speed, and unusual characteristics made it stand out from the typical asteroids and comets we encounter. But as scientists observed it more closely, they began to ask questions. Why was it moving so fast? Why did it come from so far beyond the reaches of our solar system? Could there be something more to this object than we could readily explain? What if 3IATLAS wasn't just a fragment of a distant planet or star system, but a carefully crafted tool or probe sent by an intelligence that operates on a level far beyond our own? The idea of hidden intelligence in the cosmos is not a new one. For centuries, humans have wondered if we are truly alone in the universe, or if there are other civilizations out there, hidden from our view. The search for extraterrestrial life through initiatives like SETI, Search for Extraterrestrial Intelligence, is based on the premise that advanced civilizations might exist beyond Earth, and that they may be sending signals, probes, or artifacts our way. But what if, Instead of radio signals or advanced spacecraft, alien intelligence is much more subtle. What if it's using objects like 3IATLAS to communicate, to gather information, or even to study our solar system without direct interaction? If 3IATLAS was indeed a product of alien technology, it opens up a vast new realm of possibilities. The fact that it arrived at a time when humanity was beginning to explore the stars and think more seriously about space exploration could suggest that it was sent to observe us specifically. Imagine a civilization that has been exploring the universe for millions of years, far older and more advanced than we are. What if this civilization uses objects like 3IATLAS as part of an ongoing effort to catalogue and monitor different star systems, gathering data on the conditions in each one, and possibly even on emerging intelligent life? It could be that 3IATLAS was not just a random visitor, but part of a much larger cosmic project, an ancient intelligence's way of keeping track of developing civilizations like ours, watching us from afar, perhaps to see if we are ready for contact or capable of advanced spacefaring technology. This theory invites us to ask, what if we are being watched, not by some far-off civilization planning to make contact, but by a hidden intelligence, observing our development in the shadows? Perhaps this intelligence has no interest in direct communication, but simply in watching how life and intelligence evolve across the galaxy. Perhaps, like 3IATLAS, these intelligent beings have found a way to monitor us without disrupting our natural development, sending probes or objects across vast distances and waiting to see if we are able to detect them and understand their purpose. The idea that 3IATLAS is part of a hidden intelligence's larger plan would explain some of the peculiarities of its behavior. The object moved in ways that didn't entirely align with the expected paths of typical interstellar objects. Its speed, trajectory, and interaction with the Sun were all unusual. Could these factors be the result of intelligent design, an object that is deliberately created to move in such a way that it can pass through our solar system unnoticed, or perhaps only noticed by those who are ready to understand its significance? What if the technology that powered 3IATLAS is so advanced that it can remain undetected by our current methods of observation until it passes through our solar system? What if the object's high velocity and hyperbolic trajectory were designed to ensure that it would not be bound by the Sun's gravity, and that it could complete its mission without drawing too much attention to itself? The possibilities are both intriguing and unsettling. Could the object have been designed with the ability to blend in with its surroundings, observing and gathering data without revealing its true nature? Could it have been created in such a way that we would only notice it at the exact moment it passed through our solar system, at a time when our technology and understanding of the universe were finally advanced enough to detect it? At the same time, we must ask ourselves, what would be the purpose of such an object? If 3IATLAS were truly a product of hidden intelligence, it could be an effort to quietly observe our development and our place in the universe. It could be a tool for monitoring emerging civilizations, tracking their progress as they begin to explore space. It could be that 3IATLAS is part of a larger effort to document the development of intelligent life across the cosmos, a silent witness to our own progress and, perhaps, our eventual future among the stars. This idea also leads to the question of whether there could be other objects like 3IATLAS out there, silent probes, slowly making their way through space, monitoring different star systems and planets. If this is the case, then it's possible that humanity is just one of many civilizations being quietly observed by advanced intelligence. And what if the discovery of 3IATLAS is not the end, but the beginning? What if, in the coming decades or centuries, we will detect more such objects, slowly unraveling the mystery of who or what is watching us? The presence of 3IATLAS forces us to confront a difficult truth. There is so much we don't know about the universe. We are still just beginning to understand the forces that govern space, the nature of intelligent life, and the vast potential of technological advancement. The arrival of 3IATLAS is a reminder that the universe is full of mysteries, some of which may be far older and more complex than we could have imagined. Whether it is the product of a hidden intelligence, an ancient probe sent to gather data, or simply a natural object from a distant star system, 3IATLAS forces us to ask bigger questions about our place in the cosmos. As we continue to explore the universe, we must remain open to the possibility that we are not alone, that there are forces out there we do not yet understand, and that the universe is far more complex and mysterious than we ever thought possible. Perhaps one day we will discover that 3IATLAS is just the first of many such objects, and that the answers we seek are out there, waiting for us to find them. What if the path that 3IATLAS took through our solar system wasn't solely the result of its original trajectory, but was shaped by the gravitational forces of the Sun and the planets, pulling it in directions it might not have traveled otherwise? Could the influence of gravity play a more profound role in the journey of such interstellar objects, guiding them through the cosmos in ways we don't fully understand? When 3IATLAS was first discovered, one of the most compelling features of its movement was the speed and trajectory at which it was traveling. It appeared to be moving too fast to be bound by the Sun's gravity, meaning it wouldn't stay in our solar system. Its hyperbolic trajectory suggested that it came from another star system and was passing through, only to continue its journey outward. While this observation may seem to suggest that the object was simply on a random course through the galaxy, gravity still had a significant role to play in the path it took. Gravity is one of the fundamental forces of the universe, shaping the motion of planets, stars, and galaxies. It is the force that governs the orbits of the planets around the Sun and the paths of comets, asteroids, and other objects within our solar system. But what happens when an object like 3IATLAS, which originates from outside our solar system, enters the Sun's gravitational influence? How does the Sun, with its powerful gravitational field, affect the path of an object that is merely passing through? The answer lies in what is called gravitational assist or gravitational slingshot. This phenomenon occurs when a spacecraft, or in this case, an object like 3IATLAS, uses the gravity of a planet or star to change its speed and direction. When an object passes close to a massive body like the Sun's gravity can alter its trajectory, pulling it slightly off course or accelerating it to higher speeds. While the speed of 3IATLAS was so high that it couldn't be captured by the Sun's gravity, it's possible that the Sun still played a role in influencing its path, even if only slightly. For example, as 3IATLAS approached the solar system, the Sun's gravity would have exerted a force on the object, bending its path slightly as it passed through. This gravitational interaction could have caused the object to speed up or slow down, depending on the angle at which it approached the Sunday. Even though 3IATLAS wasn't captured by the Sun's gravity, it's possible that the gravitational slingshot effect altered its course in ways we can't fully measure, contributing to its hyperbolic trajectory and its exit from the solar system. But what if there's more to this than just a simple gravitational interaction? What if the role of gravity in 3IATLAS's path was not just a passive force, but an active participant in the journey, one that influenced the object's motion in subtle and unexpected ways? Could gravity be playing a more complex role in guiding objects like 3IATLAS through space, ensuring that they travel along precise paths, even across vast interstellar distances? This possibility invites us to think about gravity not just as a force that acts on objects, but as a tool for navigation, one that could be used by advanced civilizations or even nature itself to guide objects on their way. In the case of 3IATLAS, gravity could have been a part of a larger strategy, helping to steer the object through the solar system and perhaps even directing it to a specific location. Whether this was intentional or simply the result of natural forces is still unknown, but it forces us to think more deeply about the role of gravity in shaping the universe. Additionally, the behavior of 3IATLAS raises the question of how gravity might affect objects traveling over long distances in space. The universe is filled with a vast network of gravitational influences, from the pull of distant stars to the gravity of entire galaxies. As objects like 3IATLAS travel across these vast distances, they may pass through regions of space where gravity is exerted on them by unseen forces. Could it be that, as 3IATLAS moved through space, it was subtly influenced by gravitational forces from other stars, star systems, or even dark matter forces we can't yet detect? This opens up a fascinating possibility. What if 3IATLAS was not simply moving through empty space, but was being guided by a series of gravitational forces that led it to our solar system? What if these forces were part of a larger pattern, a cosmic path that spans across vast distances and that we are only beginning to understand? Could it be that objects like 3IATLAS are not just random pieces of space debris, but part of a much larger cosmic system, one where gravity plays a key role in shaping the journeys of interstellar objects. As we consider the role of gravity in 3IATLAS's path, we are forced to acknowledge how much we still have to learn about the universe. Gravity is the fundamental force that shapes the motion of everything in the cosmos, but its role in interstellar travel is still shrouded in mystery. Could it be that gravity is not just a passive force, but a key player in guiding the paths of objects traveling through space? What if, in the future, we discover that gravity is the key to understanding how objects like 3IATLAS travel across the vast expanse of the universe, moving from one star system to another with purpose and precision? In the end, the role of gravity in 3IATLAS's path raises more questions than it answers. The object's movement through our solar system was influenced by forces beyond its initial trajectory, forces that we are only beginning to understand. Whether these forces were natural or guided by intelligence, the journey of 3IATLAS reminds us of the complexity of the universe and the need for further exploration. Could it be that 3IATLAS's journey was more than just a random passage through space? Could gravity, as a force of nature, have been part of a larger design, guiding this object to study our solar system, to observe the sun, and perhaps even to witness the rise of intelligent life on Earth? What if the timing of 3IATLAS's arrival was no accident, but a carefully chosen moment in the cosmic calendar? What if it wasn't just a random object passing through our solar system at any given time, but rather a signal, a marker, timed to coincide with humanity's growing interest in space exploration and our place in the universe? Could the object's arrival be a cosmic message, sent to us at just the right time? When 3IATLAS was discovered in 2017, it marked the first time that an interstellar object had been observed in our solar system. Its discovery raised immediate questions about its origin, purpose, and path through the cosmos. But one question that we don't often ask is this: why now? Why did 3IATLAS appear at a time when humanity was starting to make real strides in space exploration and interstellar research? Could it be that its arrival was somehow timed to coincide with our growing curiosity about the universe, our desire to understand our place in the cosmos? To explore this idea, we must consider the broader context of human history and the rapid advancements in our understanding of space in recent decades. For most of human history, we were bound to Earth, gazing up at the stars with wonder, but without the technology or knowledge to reach them. But in the last century, everything changed. We began sending probes to distant planets, landing on the moon, and launching telescopes into space to study the universe in ways that were once unimaginable. We even started to send signals out into space, hoping to make contact with extraterrestrial civilizations through efforts like the SETI program. But with all of these advancements came new questions. What if there are other civilizations out there, waiting for us to discover them? What if we are not alone in the universe? And what if we've already missed clues to this fact, waiting to be uncovered? What if 3IATLAS arrived as a sign that the universe is more complex than we ever imagined, and that we are not just passive observers of the stars, but active participants in a cosmic story that spans billions of years? The possibility that 3IATLAS's arrival was timed for a specific moment is particularly intriguing when we consider the state of our scientific knowledge and technological capabilities. In 2017, we were in the midst of a renaissance of space exploration, with renewed interest in human missions to Mars, the launch of the James Webb Space Telescope, and the development of technologies that could one day allow us to send probes to other star systems. Could it be that 3IATLAS appeared at this precise moment to challenge us, to remind us of our place in the grand scheme of the universe, and to push us to explore deeper and farther than we have ever gone before? This idea raises an important question. What if our advancements in space exploration are not just a natural progression of scientific curiosity, but part of a larger, more cosmic cycle? Could 3IATLAS's arrival be a marker of humanity's readiness to take the next step in understanding the universe? What if the object was sent or guided to appear at a moment when our technology was finally advanced enough to detect it, and our awareness of the universe was ready to expand? Of course, this is a speculative idea, and we cannot yet say for certain whether the timing of 3IATLAS's arrival was intentional or merely coincidental. However, it is worth considering the possibility that the universe, in all its vastness, is not as random as we think. Perhaps there are forces, intelligences, or cycles at work that we do not yet understand. And perhaps our encounter with 3IATLAS is part of a larger pattern that spans across the cosmos, with significant events unfolding at specific times in the development of intelligent life. As we reflect on the timing of 3IATLAS's arrival, we are also reminded of the larger cosmic timeline. The universe is not static, it is constantly evolving, with stars born and dying, galaxies forming and colliding, and planets being created and destroyed. Yet, in the grand scheme of things, our existence is but a brief flicker. In the vastness of time, human civilization is incredibly young, and we are just beginning to understand the enormity of the universe around us. In this context, the appearance of 3IATLAS might be seen as a sign, an invitation, perhaps telling us that there is much more to discover. It forces us to ask whether we are on the verge of a new era of exploration, one in which humanity takes its first steps toward understanding the true nature of the cosmos. Could 3IATLAS have been sent to us as a kind of cosmic wake-up call, a signal that we are ready to engage with the broader universe, to search for answers, and to uncover the mysteries that lie beyond our own solar system? The timing of its arrival also raises questions about the nature of space exploration itself. As we continue to probe the depths of space, studying distant stars and exoplanets, searching for signs of life, and developing technologies to reach other star systems, we may be preparing for something greater than we can currently imagine. Perhaps the appearance of 3IATLAS is just the beginning, the first of many such encounters with objects from beyond our solar system, each one guiding us closer to a deeper understanding of the universe. And what if the timing of this encounter means that we are not the first to detect such an object? Could other civilizations, far more advanced than our own, have detected 3IATLAS long before we did? Could they have sent objects like it to observe us, or perhaps to study our civilization from afar, just as we are now studying it? In any case, the arrival of 3IATLAS is a pivotal moment in human history, one that will resonate for years to come. Whether its arrival was a coincidence or part of a larger plan, its passage through our solar system has forced us to question our place in the universe, to wonder about the mysteries that lie beyond the stars, and to look forward to the discoveries yet to be made. As we continue to study 3IATLAS and prepare for future encounters with interstellar objects, we are reminded that the timing of our understanding of the universe may be just as important as the discoveries themselves. The universe has its own rhythm, its own cycles, and perhaps 3IATLAS's arrival marks the moment when humanity's awareness of the cosmos shifts forever. What if the universe operates on a scale of time so vast that the concept of now is insignificant? What if 3IATLAS, in all its mystery, is not just an isolated event, but a part of a much larger cosmic calendar, one that spans eons, marking moments of significance in the slow dance of interstellar objects, stars, and galaxies? Could the universe itself have a rhythm, a timing so vast that our understanding of it is limited to the briefest of moments? To fully appreciate the significance of 3IATLAS's passage through our solar system, we must first consider the vastness of time that shapes the universe. The life of our sun, for example, is measured in billions of years. It has existed for about 6 billion years, and it will continue to burn for another 5 billion, before eventually exhausting its fuel and transforming into a red giant. The Earth itself has been around for about 5 billion years, and life has existed on this planet for approximately 5 billion years. But in the grand scale of cosmic time, even the sun's lifetime is fleeting. When we talk about cosmic events, we are speaking of periods of time that stretch far beyond human experience, far beyond the reach of any human civilization. Objects like 3IATLAS, which come from other star systems, carry with them the echoes of an even longer history, one that stretches across light years and spans millions, if not billions of years. These objects are not just traveling through space, they are also traveling through time. And as they move from one star system to another, they carry with them the marks of their long journey. Perhaps, as 3IATLAS passed through our solar system, it was not just marking a point in time, but also tracing the steps of an interstellar journey that began long before our sun was born. The trajectory of 3IATLAS, which was described as hyperbolic, suggests that the object was not bound by the sun's gravity. was only passing through our solar system on its way to another part of the galaxy. Its high velocity meant that it would not remain in our system, and this made its arrival all the more intriguing. It was as though it had been moving for eons, an ancient traveler crossing through the vast distances of space and time, a visitor from another star system, moving in a trajectory that was part of a much larger cosmic calendar. But what does this cosmic calendar look like? How do objects like 3IATLAS fit into the long, slow rhythm of the universe? Perhaps they are like waypoints, markers of time that indicate key moments in the history of the galaxy, moments when objects from one star system cross into another. Could there be a deeper pattern to these movements, a timing that we are only beginning to recognize? Could the passage of 3IATLAS be part of a cosmic cycle that repeats itself over vast spans of time, an ongoing process of objects moving through the galaxy, carrying with them the remnants of distant stars and civilizations? In the broader context of galactic movements, 3IATLAS's passage is just a small event. It is a moment in the life of the universe, a brief blip in the cosmic timeline. But for us, it is a reminder of how small our understanding of time really is. We live our lives in the span of mere decades or centuries, measuring our experiences against the fleeting moments of human history. But the universe operates on a much grander scale, where the movement of stars and objects like 3IATLAS spans millions or billions of years. We may never fully comprehend the rhythms of the cosmos, but every discovery, every moment, like the passing of 3IATLAS, brings us closer to understanding our place in the vast cosmic story. The idea of the cosmic calendar forces us to think differently about time. It challenges our perspective, asking us to step outside of our limited experience and to view the universe not as a series of isolated events, but as a continuous flow, one in which each object, each movement, is part of a larger, interconnected whole. 3IATLAS's journey is just one piece of a much larger puzzle, one that has been unfolding for billions of years. Its passage through our solar system may have been a random event, or it may have been part of a grander design. Either way, it is a reminder that the universe moves in ways we cannot always predict, and that our place within it is just a fleeting moment. As we continue to study 3IATLAS and other interstellar objects, we will no doubt learn more about the larger forces at play in the cosmos. We may discover that the universe is filled with objects like 3IATLAS, moving through space on journeys that span across light years and eons. Each of these objects may have its own story to tell, a story that is part of the larger cosmic calendar, a story that is still unfolding, one we are only just beginning to understand. In the end, the arrival of 3IATLAS reminds us of how much more there is to discover, how much more there is to learn about the universe and our place within it. The object's journey is a testament to the vastness of time, a reminder that the universe is much older, much more complex, and much more mysterious than we can fully grasp. As we continue to explore the cosmos, we are bound to encounter more objects like 3IATLAS, each one a marker in the cosmic timeline, each one carrying with it the secrets of the stars and the history of the galaxy. And perhaps, one day, we will begin to understand the true purpose of their passage and the role they play in the larger story of the universe. What if 3IATLAS's passage through our solar system was not simply the random journey of an interstellar object, but a deliberate message, a cosmic communication sent from a distant civilization, perhaps trying to reach us? What if the object itself, in all its peculiarities, was not just a fragment of space, but a carrier of knowledge, information, or even a warning, purposefully designed to arrive at this exact moment in human history? When 3IATLAS was first detected, it was observed to be an interstellar object traveling at an incredible speed, not bound by the gravitational pull of the Sunday. Its trajectory, velocity, and unusual characteristics raised questions that went beyond the realm of traditional astronomy. Was it simply a random fragment of space debris, or was there more to it? Could it be part of a larger, more deliberate cosmic plan, a signal or message from an intelligence beyond our own? The idea of messages from extraterrestrial civilizations is not new. For decades, scientists have speculated about the possibility of advanced life beyond Earth and how such civilizations might communicate. One of the most well-known projects in this field is SETI, Search for Extraterrestrial Intelligence, which scans the sky for radio signals or other forms of communication from distant civilizations. But what if the message from an advanced civilization isn't in the form of radio signals or electromagnetic waves, but rather in the form of an object, an interstellar probe, much like 3IATLAS? If 3IATLAS is indeed a message, its arrival is deeply significant. Its high velocity, unusual trajectory, and its journey from a distant star system could be deliberate features of its design. The fact that it passed through our solar system at precisely the right moment, when humanity is beginning to develop its capabilities in space exploration and interstellar research, suggests that this might be a timed event. Could this be a sign that the universe is filled with more than just random objects? Could it be that intelligent civilizations have already sent objects like 3IATLAS to other star systems, waiting for us to recognize them, to decode their meaning? The idea of 3IATLAS as a message raises intriguing possibilities. The object's movement could be interpreted as a form of communication, not by direct contact, but by the very act of its passage through our solar system. Perhaps it is designed to spark a series of questions, to inspire us to think more deeply about the cosmos, about our place in it, and about the potential for intelligent life beyond our world. The very mystery of 3IATLAS could be the message itself, a cosmic riddle meant to challenge our understanding, to push us toward new discoveries, and to open our minds to the possibilities of life in the universe. If 3IATLAS is a message, what could it be trying to tell us? One possibility is that it could be offering us a glimpse into the nature of interstellar travel, suggesting that advanced civilizations have the technology to send objects across vast distances and communicate in ways we have yet to understand. It could be a sign of the potential for future contact with other intelligent species, a reminder that we are not alone in the universe, and that we are on the verge of discovering the broader galactic community. It might even be a kind of cosmic test, an invitation for us to expand our horizons and look beyond our planet, challenging us to think bigger and more boldly about our future in space. Another possibility is that 3IATLAS could be a message of warning. The idea of alien civilizations sending objects to other star systems is often associated with the potential for peaceful contact, but it's also possible that such messages could be more cautionary. Could 3IATLAS be a warning about the dangers of technological advancement? What if it's an attempt by an advanced civilization to communicate with us, urging us to be careful as we reach for the stars, reminding us that there are forces in the universe that we are not yet ready to understand or control? The object's seemingly erratic path, its strange features, and its distance from our solar system might be a subtle reminder of the risks inherent in space exploration, risks that we may not yet fully comprehend. In either case, whether the message is one of peace, caution, or simply a spark of curiosity, 3IATLAS forces us to ask deeper questions about our place in the universe. If this object is a message from an alien civilization, it raises profound questions about how such civilizations might communicate, what they might want to tell us, and how we would respond. Could we decode the message hidden within 3IATLAS's passage, or would it remain an enigma, forever beyond our grasp? The idea of 3IATLAS as a message also raises questions about the nature of interstellar communication itself. If 3IATLAS was indeed sent to communicate with us, what other forms of communication might exist in the universe? Could objects like 3IATLAS be just one of many such messages, sent across the stars by civilizations that have come before us, waiting for us to discover them? Perhaps there are other objects, hidden in the vastness of space, just waiting to be found, each one carrying its own message, its own piece of cosmic knowledge. And if this is the case, how long will it take before we discover the next message? Could 3IATLAS be the first of many interstellar objects, each one offering us a new piece of the puzzle, a clue about our place in the universe? In the end, the true nature of 3IATLAS remains a mystery. Whether it is simply a piece of space debris or a carefully designed message from an alien civilization, its passage through our solar system forces us to confront the larger questions about life, intelligence, and our place in the cosmos. As we continue to explore the stars, we must remain open to the possibility that we are not alone, that the universe is full of messages, waiting to be discovered, waiting for us to decode and understand them. Perhaps 3IATLAS is just the beginning of a larger story, one that will unfold over time, revealing more about the nature of the cosmos and our place within it. What if 3IATLAS is not an isolated anomaly, but just the first of many interstellar objects to pass through our solar system? What if, as our technology advances, we discover that our solar system is teeming with visitors from distant stars, silently passing through the cosmic expanse, yet largely unnoticed by humanity? The discovery of 3IATLAS has raised a fundamental question. Are we truly aware of the objects that cross through our solar system? Or are we simply missing them, blind to the cosmic traffic that flows in and out of our neighborhood? The detection of 3IATLAS in 2017 was groundbreaking. It was the first time humanity had discovered an interstellar object, something that had traveled from outside our solar system and made its way into our midst. This discovery was significant not just because it was the first known interstellar object, but also because it revealed a glaring gap in our understanding of the universe. Until that moment, astronomers and scientists had assumed that interstellar objects were incredibly rare. They believed that objects passing through our solar system from distant star systems would be few and far between, and that it would take years, perhaps even decades, to find another one. But 3IATLAS has opened our eyes to a new possibility. What if such objects are more common than we realize? Since its discovery, scientists have begun to ask whether 3IATLAS was an isolated case or just the first known example of a much larger phenomenon. With improved technology, more sophisticated telescopes, and better detection methods, we may be able to identify many more interstellar objects in the coming years. If this is the case, then 3IATLAS may have simply been the first of many such visitors to our solar system. The detection of future interstellar objects could provide us with valuable insights into the dynamics of the universe and our place within it. By studying these objects, scientists may be able to learn more about the processes that occur in other star systems, how objects are ejected from their home systems, and the mechanics of interstellar travel. In a way, interstellar objects could serve as messengers from the farthest reaches of the galaxy, offering us glimpses of the conditions and histories of distant stars, planets, and even entire civilizations. And yet, despite the potential value of these objects, we are still barely scratching the surface of our ability to detect them. As we continue to search for other interstellar objects, we must also consider how many we might have missed. Could there have been other objects like 3IATLAS that passed through our solar system undetected? What if we simply lacked the tools or the knowledge to observe them? Our detection methods are still in their infancy, and with advances in technology, we may soon be able to see objects that were previously invisible to us. The more we explore, the more likely it is that we will encounter other interstellar visitors, each one offering us new insights and challenges. One of the main challenges in detecting interstellar objects is their speed. Objects like 3IATLAS move incredibly quickly, often at speeds that make it difficult to track them in real time. Their velocity means that they don't stay in our solar system for long, making it harder for astronomers to spot them before they've already passed through. The faster an object is moving, the more difficult it is to detect it in time to study it thoroughly. But what if, as our observation technologies improve, we develop ways to track these objects earlier in their journey, giving us more time to study them before they leave our solar system? Another factor that complicates the search for interstellar objects is the vastness of space itself. The distance between stars is so great that interstellar objects travel across vast stretches of space, often passing through areas where they are not easily observed. Our solar system, while vast in itself, is just a tiny speck in the immense expanse of the Milky Way galaxy. The chances of detecting an object from another star system are slim, simply because the universe is so vast. Yet, the fact that we were able to detect 3IATLAS suggests that our capabilities are improving, and that we may soon be able to see more interstellar objects as they approach our solar system. If we do begin to detect more interstellar objects, what could we learn from them? For one, these objects could provide us with information about the conditions of other star systems. The composition, speed, and trajectory of these objects could give us clues about the environments from which they came. For example, the analysis of 3IATLAS revealed that it was a dark red color, suggesting that it was composed of materials that are common in star-forming regions. This suggests that the object may have come from a star system that is in an earlier stage of its life cycle, where the conditions are vastly different from those in our own solar system. In the future, by studying the composition and characteristics of other interstellar objects, we could gain a better understanding of the diversity of planetary systems in our galaxy, as well as the processes that drive the formation of planets, asteroids, and other celestial bodies. Interstellar objects could also help us refine our understanding of the dynamics of the Milky Way galaxy. The way in which objects are ejected from their home star systems and travel across the galaxy could reveal important information about the structure of the galaxy, the influence of gravity on celestial bodies, and the forces that shape the movements of stars and planets. By studying these objects, we may be able to develop more accurate models of galactic dynamics, and perhaps even gain insight into the future of our own solar system. However, the search for interstellar objects is not just about scientific discovery. It is also a philosophical question. The detection of these objects raises the possibility that we are not alone in the universe, that our solar system is part of a much larger, more interconnected cosmos. Each interstellar object that passes through our solar system is a reminder that the universe is teeming with activity, even if we cannot yet fully comprehend the scale or the complexity of that activity. We are only beginning to explore the mysteries of the stars, and as we continue to search for other interstellar objects, we may one day uncover answers to some of the most profound questions about life, the cosmos, and our place in the universe. As we look ahead, we must ask, how many interstellar objects are out there, waiting to be discovered? Could the next object we encounter be just as significant as 3IATLAS, or could it offer us even more insight into the nature of the universe? The search for interstellar objects is just beginning, and with each new discovery, we move closer to unlocking the secrets of the cosmos. What if 3IATLAS, in all its mystery, is more than just an object, more than just a message? It's a sign of something much greater, a subtle reminder that we are not alone in the universe. What if, hidden in the cosmos, there are other objects, other travelers like 3IATLAS, carrying the fingerprints of distant life, civilizations, or biospheres? Could the passage of 3IATLAS be an indication that the universe is teeming with life, waiting to be discovered? For decades, scientists have been asking the question, are we alone in the universe? The search for extraterrestrial life is one of humanity's most profound endeavors. From sending radio signals into deep space to scanning distant exoplanets for signs of habitability, we have been trying to answer this question for as long as we've had the technology to look beyond our world. Yet, despite the advancements in technology and the many attempts to find signals or signs of life, the truth remains elusive. But the discovery of 3IATLAS, an interstellar object from outside our solar system, has added a new dimension to this search. When 3IATLAS entered our solar system, it was the first object from another star system to be observed. While its origins are still a mystery, its very presence in our solar system forces us to consider the possibility that we are not the only intelligent civilization in the universe. The object's journey, traveling from one star system to another, suggests that other civilizations, perhaps far older than ours, might have already discovered the vast reaches of space, sending objects like 3IATLAS across the galaxy to explore, gather data, or communicate. The possibility of life beyond our solar system is something that has captivated scientists, philosophers, and dreamers for centuries. The sheer vastness of the universe, filled with billions of stars, each potentially hosting planets, suggests that the conditions for life might exist elsewhere. If life can emerge here on Earth, then why not elsewhere in the universe? It is a question that has inspired generations of scientists, and it lies at the core of many scientific missions, such as NASA's search for life on Mars, or the study of exoplanets that orbit distant stars. But the discovery of an object like 3IATLAS takes this question to an entirely different level. What if 3IATLAS is more than just a fragment of a distant star system? Could it be a messenger from a distant civilization, sent to explore or communicate with us, just as we are now sending probes into the depths of space? The very idea that we might not be alone in the universe is both exciting and humbling. If 3IATLAS is a product of intelligent design, it suggests that the universe may be full of advanced civilizations, each one sending probes, satellites, or even artifacts across the stars, waiting for us to find them. It raises the tantalizing possibility that other civilizations might have been doing the same thing for millennia, observing the cosmos, sending probes, and studying planets like ours. And what if the object's path through our solar system wasn't just a random event, but part of a larger, intentional exploration? 3IATLAS Atlas's trajectory suggests that it was moving with a purpose, passing through our solar system on its way to other parts of the galaxy. Perhaps it was part of a mission, part of a much larger plan, to gather data on the Sun, the planets, or even on Earth itself. If so, what does this say about the potential for life in other parts of the galaxy? Could there be intelligent beings out there who are actively exploring, searching for signs of life, or even waiting for a moment when we are ready to communicate? Of course, these ideas remain speculative. We have no direct evidence that 3IATLAS is a product of intelligent design, nor do we have proof that it was sent as a message from another civilization. But the mere possibility raises profound questions about life beyond our solar system. Even if 3IATLAS is a natural object, its passage through our solar system serves as a reminder that the universe is vast, teeming with objects, phenomena, and potential that we have yet to fully understand. It forces us to consider the possibility that life, intelligence, and civilizations may exist elsewhere in the universe, and that the very act of discovering 3IATLAS is a step toward unraveling that mystery. The search for life beyond our solar system is far from over, and the discovery of 3IATLAS only adds to the intrigue. As we continue to study distant exoplanets, sending probes to the outer reaches of the solar system, and exploring the depths of space, we must remain open to the possibility that we are not alone. The idea that life, in some form, may be widespread throughout the galaxy is no longer just a distant dream. It is a real and tangible possibility, one that could be closer than we think. If 3IATLAS is indeed a sign of life beyond our solar system, it could be just the beginning. Perhaps in the future, we will detect more interstellar objects, each one offering us more clues, more evidence that the universe is teeming with life. Maybe, just maybe, 3IATLAS is the first of many objects to visit us, each one carrying the echoes of a distant civilization. Perhaps the next object we detect will be a message, or a sign that we are on the verge of a much larger discovery. The arrival of 3IATLAS reminds us of how little we truly know about the universe. It forces us to reconsider the nature of life, intelligence, and our place in the grand scheme of things. As we continue to explore the cosmos, we are likely to encounter more mysteries, more questions that we may not yet be able to answer. But perhaps, with each discovery, we are inching closer to a revelation that could change everything we know about the universe and our place within it. Could it be that we are part of something much larger, a vast galactic community of life, waiting to be discovered? What if 3IATLAS is just the beginning of an era of cosmic discovery, an era in which we are no longer alone but part of a larger, interconnected cosmos? What if the material composition of 3IATLAS, the very substance it's made of, holds the key to understanding not only its origins, but also the secrets of its mission, its design, and possibly even the nature of the universe itself? What if the clues hidden within the object's composition are pointing us toward answers we've long sought but haven't yet discovered? When 3IATLAS passed through our solar system, it piqued the curiosity of scientists around the world, not only because it was the first known interstellar object to be detected, but also because of its unusual properties. Its shape, speed, and trajectory were unlike anything we had seen before, but so was its composition. The object was found to be darker than any object we had encountered from our solar system. It reflected far less light, which led scientists to speculate about the materials that made up its surface. This lack of reflectivity, combined with the object's reddish hue, hinted at a composition that was unlike anything we had encountered in our own solar system. The mystery of 3IATLAS's composition is part of what makes the object so intriguing. On Earth, we typically associate such dark and reflective materials with the rocky bodies of our own solar system, comets, asteroids, and moons that have undergone billions of years of transformation under the influence of our sunday. But 3IATLAS was not a comet or an asteroid. It was a visitor from another star system, suggesting that its materials may be entirely different from the objects that make up our own solar system. Could the object be composed of materials we have yet to discover? Could it be that 3IATLAS represents a class of interstellar matter that is entirely unique, one that could hold the key to understanding the building blocks of other star systems? The red hue of 3IATLAS is also intriguing. When scientists studied the object's light curve and spectral data, they found that the object's surface absorbed more light in the blue and ultraviolet parts of the spectrum, but reflected much more in the red. This suggests that the materials on 3I/ATLAS are rich in complex organic compounds, similar to the substances that are found on comets, but with differences that might point to an entirely different origin. Some scientists have speculated that the object might be composed of metal-rich rock, much like the asteroid belt in our solar system, while others suggest that it could be a chunk of primordial material that originated in a star-forming region, where conditions are much more volatile and chaotic than in the more stable parts of our galaxy. What if the composition of 3I/ATLAS contains the signature of its home star system, carrying with it clues about the kind of star it formed around, the types of planets and moons that might have orbited it, and even the kinds of life that might have existed there? If the object was sent from an intelligent civilization, it might contain materials that were intentionally selected or designed to survive the rigors of interstellar travel. Could it be that the object's composition, its unusual materials and chemical makeup, was engineered to endure the harsh conditions of space travel and to survive for billions of years without disintegrating? The study of 3I/ATLAS's composition could also reveal valuable information about the way objects form in different star systems. We know that our solar system was formed around 4.6 billion years ago from a swirling cloud of gas and dust. Over time, this material coalesced into the planets, moons, and other bodies we see today. But what if 3I/ATLAS is a relic from a much older star system, one that underwent a different process of formation? What if the object's material composition is a glimpse into the very building blocks of star formation, showing us how different stars and systems create their planets, asteroids, and comets in ways that differ from our own solar system? If 3I/ATLAS is indeed a probe or a designed object, its composition may also provide clues about the technology used to create it. How was it built to survive such a long journey across the cosmos? Was it constructed from materials that could withstand the vacuum of space, cosmic radiation, and extreme temperatures? If 3I/ATLAS is a product of intelligent design, its composition could reveal the kinds of materials used by an advanced civilization to create tools, probes, or vehicles for interstellar travel. Could this object, with its unique properties, hold the key to understanding the technologies of other civilizations and their ability to navigate the vast distances between stars? One of the most fascinating aspects of studying 3I/ATLAS's composition is that it forces us to consider the possibility that the universe is filled with materials we have yet to discover, materials that exist beyond the realms of our own solar system. Our understanding of the cosmos is based on a limited sample, our solar system, our planet, and the objects we have observed in the nearby universe. But what if there are entire classes of materials out there, far beyond our current understanding, that are central to the formation of stars, planets, and intelligent life? 3I/ATLAS may be offering us a glimpse into this hidden world of interstellar matter, a world that could hold the answers to questions we have only just begun to ask. In many ways, the composition of 3I/ATLAS serves as a metaphor for our understanding of the universe itself, vast, mysterious, and still largely unknown. As we study the object, we are reminded that there is so much more to discover, so much more to learn about the building blocks of the universe. The materials that make up 3I/ATLAS could provide us with clues not just about the object itself, but about the nature of the galaxy, the conditions that support life, and the potential for life beyond our own planet. As we continue to explore and study 3I/ATLAS, the mystery of its composition will undoubtedly continue to unfold. We may discover new materials, new chemical compounds, and new processes that we had never considered before. Each new revelation about the object's makeup will bring us closer to understanding its origins and its purpose, and perhaps even the broader mysteries of the universe. And perhaps, as we uncover the secrets of 3I/ATLAS, we will find that its composition is more than just a scientific puzzle. It is a key, a clue, to unlocking the greatest mystery of all, the potential for life, intelligence, and civilization beyond our solar system. What if 3I/ATLAS is not just an object traveling across space, but a testament to the advanced technologies of an extraterrestrial civilization, one far beyond our own capabilities? What if its journey across light years of space, silently passing through our solar system, is the result of technologies that we have yet to develop? Technologies that could one day allow us to explore other star systems, visit distant worlds, and travel beyond the confines of our own solar system? The discovery of 3IATLAS has opened our eyes to the possibility that interstellar travel is not just a concept from science fiction, but a reality that might one day be achievable. For years, scientists and researchers have speculated about the technologies that might make such long-distance travel possible, but the reality of 3IATLAS's passage through our solar system suggests that advanced civilizations, possibly far older than ours, have already mastered these technologies. One of the most fascinating questions raised by 3IATLAS is how such an object could travel across such vast distances. The object's velocity and trajectory suggest that it was traveling at an incredibly high speed, far faster than any object we have ever sent out into space. The fact that it arrived in our solar system and is now continuing its journey outward means that 3IATLAS has already completed a journey that could have taken millions or even billions of years. So how did it manage this journey? What kind of propulsion, energy source, or technology allowed it to travel across the immense distances between stars? The idea of interstellar travel often conjures images of spacecraft powered by advanced propulsion systems, engines that can push objects to speeds fast enough to overcome the vast distances of space. In recent years, scientists have developed theoretical models for such technologies, such as ion drives, nuclear propulsion, or even the concept of a warp drive that could allow a spacecraft to bypass the limitations of light speed. But these ideas are still far from being realized in practical terms. However, the presence of 3IATLAS raises an intriguing possibility. What if these technologies already exist, used by an advanced civilization to send probes across the galaxy? Perhaps 3IATLAS is the result of a propulsion system that we are only beginning to understand. If it was sent by an extraterrestrial civilization, it could have been equipped with a propulsion technology that allowed it to travel at velocities far beyond our current capabilities. This would mean that such civilizations have already overcome the challenges of interstellar travel, finding ways to sustain and power long journeys across light years of space. The sheer speed and trajectory of 3IATLAS suggests that it was not simply drifting, but that its motion was guided by some kind of propulsion system, one capable of sustaining high velocities over incredibly long periods. What if the propulsion system behind 3IATLAS is based on principles that we have not yet discovered or understood? We know that objects in space move in accordance with the laws of physics, but there could be technologies or methods for propulsion that lie outside the bounds of our current scientific understanding. Could 3IATLAS be a product of such technologies, an example of a propulsion system that operates on principles we have yet to unlock? If so, this would not only revolutionize our understanding of space travel, but it could open up entirely new possibilities for exploration, discovery, and perhaps even communication with other civilizations. The energy required to power such long journeys is another area where advanced technologies might come into play. If 3IATLAS was designed to travel across the vast distances between stars, it would need a reliable energy source that could sustain its journey over millions or billions of years. Could it be that the object was powered by a form of energy that is far more efficient than anything we currently use? Perhaps it harnessed energy from its environment, drawing power from the stars it passed by, utilizing cosmic radiation, or even tapping into the energy of dark matter or dark energy, forces that we know little about but are thought to exist throughout the cosmos. The ability to harness such energy would make interstellar travel possible, and perhaps this is what enabled 3IATLAS to travel so far and so fast. Beyond propulsion and energy, 3IATLAS also raises questions about the materials and technologies required to build such an object. The object's composition, as we've already discussed, suggests it is made from materials that we are not yet fully familiar with, possibly materials that are resistant to the extreme conditions of space travel. Could it be that the creators of 3IATLAS used technologies to manipulate materials at a molecular level, constructing a vessel that could endure the intense radiation, extreme temperatures, and the passage of time? The fact that 3IATLAS arrived intact after such a long journey suggests that its creators had mastered the art of building resilient, long-lasting structures capable of surviving the harshest conditions in space. But the implications of 3IATLAS's presence extend beyond the question of technology. What if 3IATLAS was not just a probe, but part of a larger interstellar program, one that involves sending out probes to explore distant star systems, gathering data and observing the conditions of various planets and solar systems? If advanced civilizations have already mastered the technologies of interstellar travel, it is conceivable that they might have launched such a program millions or billions of years ago, sending out probes like 3IATLAS to explore the galaxy, to catalog different worlds, and to collect information on the emergence of intelligent life. Perhaps 3IATLAS is just one of many such probes, silently passing through our solar system on its way to another part of the galaxy. For us, the discovery of 3IATLAS is both a challenge and an invitation. It challenges our understanding of the possibilities of space travel, propulsion, and energy. It forces us to rethink what we know about the limits of human achievement and the potential for exploration beyond our solar system. At the same time, it invites us to imagine a future where we, too, might one day master the technologies of interstellar travel, sending our own probes to distant stars, and perhaps even reaching out to other civilizations. As we study 3IATLAS and continue to explore the cosmos, we are reminded that we are still at the beginning of our journey. We have only begun to scratch the surface of what is possible in space exploration, and the discovery of interstellar objects like 3IATLAS is a sign that there is much more to learn, much more to discover, and perhaps much more to achieve. The role of advanced technologies in space exploration is still unfolding, and as we unlock the mysteries of the cosmos, we may one day find that the key to the stars lies in the technologies we have yet to imagine. What if the Sun, our brilliant and life-giving star, holds secrets about the movement of interstellar objects like 3IATLAS that we have yet to uncover? What if the influence of our Sun extends far beyond what we can see, shaping the paths of objects that pass through our solar system in ways we do not yet fully understand? Could the gravitational and energetic forces of our Sun play a crucial role in guiding or altering the course of interstellar travelers, whether by chance or design? The arrival of 3IATLAS from another star system is an extraordinary event that challenges our understanding of the interactions between interstellar objects and our solar system. When it was detected, the object was traveling at a speed too high to be captured by the Sun's gravity. Its hyperbolic trajectory indicated that it was only passing through, rather than being pulled into orbit. However, the Sun's gravitational pull still exerted some influence on the object, bending its trajectory and shaping the way it interacted with our solar system. At first glance, it might seem that the Sun had little effect on 3IATLAS, given its high velocity and the fact that the object didn't fall into the Sun's gravitational well. However, even the most seemingly insignificant gravitational interactions can have far-reaching effects on the movement of interstellar objects. Gravity, after all, is the most fundamental force shaping the motion of celestial bodies, and the Sun's massive gravitational field extends far beyond the planets, reaching into the interstellar space surrounding our solar system. As 3IATLAS approached the Sun, its trajectory was inevitably affected by the Sun's gravity, though not enough to capture it. The object's path was likely altered by the gravitational force of the Sun in subtle ways, especially given the high speeds at which it was traveling. Gravitational interactions of this nature are a key part of how objects from outside our solar system, whether asteroids, comets, or even interstellar dust, interact with the solar system. The Sun's gravity serves as a cosmic guide, subtly bending the paths of objects that pass through the system, whether they are on their way in or out. One of the most fascinating aspects of 3IATLAS's passage is how it interacted with the Sun's solar wind. The solar wind is a stream of charged particles, mainly electrons and protons, that is constantly emitted by the Sunday. These particles travel outward from the Sun, sweeping across the solar system and interacting with the objects within it. While most objects within our solar system are affected by the solar wind, 3IATLAS was moving so quickly and from such a distance that its interaction with the solar wind would have been minimal. Nonetheless, its brief encounter with our Sun's energetic particles raises the question of how the solar wind could have affected the object's surface, its trajectory, and perhaps even the information it might have gathered during its journey. Another intriguing aspect of the Sun's influence on interstellar objects is its role in the heliosheath, the region at the outer edge of our solar system, where the solar wind slows down and interacts with the interstellar medium. The heliosheath marks the boundary between the solar system and the greater galaxy beyond, and it is here that the solar wind's influence begins to dissipate. Objects passing through this boundary, like 3IATLAS, are exposed to the transition between the Sun's influence and the quiet expanse of interstellar space. The interactions at this boundary are not well understood, but they may have a significant impact on the motion and behavior of interstellar objects as they cross into and out of our solar system. What if the Sun's influence extends beyond just gravitational pull or solar wind? Could the Sun have played a role in the object's apparent speed, trajectory, or composition? The Sun is more than just a source of light and heat. It is a massive engine, continuously emitting energy in the form of radiation and particles. It is possible that the Sun's energy, in the form of electromagnetic radiation, might have had some effect on 3IATLAS as it passed through our solar system. Could the energy from the Sun have altered the object in some subtle way, affecting its surface composition, its movement, or even the way it interacted with the cosmic radiation of space? The study of how objects like 3IATLAS interact with the Sun offers an exciting opportunity to explore the mechanics of interstellar travel. It raises questions about how the solar system influences objects that pass through it, and whether our Sun serves as a kind of cosmic gatekeeper, guiding the movement of interstellar objects as they approach or depart. This could have far-reaching implications for our understanding of how galaxies and star systems interact, how matter and energy are exchanged across the cosmos, and how celestial objects travel through the vast distances of space. But what if the Sun's influence goes even deeper? What if it is not just the gravitational forces and the solar wind that shape the movement of objects like 3IATLAS, but some more subtle, hidden force that we have yet to detect or understand? Could the Sun's energy, in ways we don't yet comprehend, be guiding interstellar objects along their paths, ensuring that they travel in a manner consistent with the rhythms of the cosmos? This possibility remains speculative, but the idea that our Sun could play a more profound role in shaping the movement of objects across the galaxy is one that is worth exploring. As we continue to study 3IATLAS and other interstellar objects, we must remain open to the idea that the Sun's influence is not limited to the objects within our solar system. Its reach extends far beyond what we can see, and its gravitational, electromagnetic, and energetic forces may shape the paths of objects that pass through our cosmic neighborhood. 3IATLAS's brief visit may have been a subtle reminder of the larger forces at play in the universe, forces that we are only beginning to understand. The role of the Sun in shaping the path of interstellar objects challenges us to think beyond the limits of our current knowledge. It forces us to reconsider our understanding of how objects move through space and how our solar system fits into the broader fabric of the galaxy. And as we continue to explore the cosmos, we will no doubt uncover new insights into the forces that govern the universe. Insights that could one day help us unlock the secrets of interstellar travel, cosmic navigation, and our place in the vast, interconnected web of the stars. What if 3IATLAS's arrival in our solar system wasn't as much of a surprise as we think? What if, with our current technological limitations, we simply missed the object's earlier approach? Could it be that 3IATLAS passed through our solar system long before it was detected, slipping under our radar due to the vastness of space and the limitations of our observation tools? Could the first interstellar object we've ever observed have been seen earlier, if only we had the means to detect it? The discovery of 3IATLAS was nothing short of groundbreaking. It was the first known interstellar object to pass through our solar system, and its detection in 2017 sent shockwaves through the scientific community. But its detection also raised a crucial question. Could we have detected it sooner? Could there have been earlier signs of 3IATLAS's approach that we missed? Could other objects like it be out there, silently passing through our solar system, waiting for us to notice? When we think about interstellar objects, we tend to focus on objects that are in our solar system or near its boundaries, those within our immediate observational reach. However, the universe is vast, and the distances between stars are immense. The likelihood of detecting an object like 3IATLAS early on is slim, especially given the speed at which it was traveling. Objects from other star systems, moving at high velocities, can be difficult to detect until they are relatively close. Even with the advanced telescopes and instruments we have today, spotting such objects requires incredibly precise measurements and timing, as well as a deep understanding of the forces that govern their movement. For 3IATLAS, the situation was no different. It wasn't until the object was already inside our solar system that astronomers were able to identify it. The object's high velocity and and unique trajectory made it stand out from the typical asteroids and comets that pass through the solar system. But despite its distinct characteristics, 3I/ATLAS could have remained undetected for much longer if it hadn't been for the specific set of circumstances that led to its discovery. In fact, scientists have speculated that 3I/ATLAS may have been visible months, or even years, earlier than it was, but our instruments were simply not tuned to detect it in time. One of the primary challenges in detecting interstellar objects like 3I/ATLAS is their speed. Objects that come from outside our solar system move at much higher velocities than those that are bound by our sun's gravity. This means they don't linger in our solar system for long. By the time they are detected, they may already be moving away, making it difficult to track them thoroughly. With 3I/ATLAS, astronomers had to rely on the object's faint light and its movement to identify it. But by the time they noticed it, the object had already passed through much of our solar system. Even with advanced telescopes, detecting objects like 3I/ATLAS presents a number of challenges. The object was moving so fast that it didn't appear in the usual spots where we might look for such objects, and its faintness made it harder to spot in the early stages of its approach. Additionally, its trajectory was not aligned with the orbits of the planets, which meant that it wasn't passing through areas that were regularly monitored by our space observation programs. In other words, even though 3I/ATLAS was moving through our solar system, it wasn't in the places where we typically look for objects like asteroids and comets. The fact that 3I/ATLAS was detected at all is a testament to the advancements in astronomical technology. The object's discovery was made possible by the Atlas Asteroid Terrestrial Impact Last Alert System survey, which was designed to identify potential threats to Earth, including near-Earth asteroids. Thanks to the Atlas system's ability to spot faint objects in the night sky, 3I/ATLAS was detected before it could slip entirely out of view. However, this kind of detection is still rare, and the chances of spotting other interstellar objects in the future will depend on the development of even more advanced technologies and observational techniques. This raises a crucial question. How many other objects like 3I/ATLAS have passed through our solar system unnoticed? Could there be other interstellar visitors drifting through space that we simply haven't been able to detect yet? The possibility that there are more objects like 3I/ATLAS out there, objects from distant star systems, silently traveling through our solar system, is both exciting and humbling. It suggests that there is much more to the universe than we can see, and that our current detection methods may only be scratching the surface. As our observational technologies continue to improve, we are likely to detect more interstellar objects, perhaps even before they enter our solar system. The ability to detect these objects earlier in their journey would give us more time to study them, to learn about their composition, their origins, and the forces that guided them across light years of space. It would also give us a better understanding of the dynamics of the galaxy and the movement of objects between star systems, providing us with valuable insights into the nature of the cosmos. Perhaps in the future, we will develop more sophisticated detection methods, telescopes that can spot interstellar objects from farther away, sensors that can detect objects moving at high velocities, and instruments that can measure faint light from objects deep in space. As we refine our understanding of the cosmos and our ability to observe it, we will likely find that 3I/ATLAS is just the beginning. More objects, more visitors from distant stars may come into view, offering us the chance to learn more about the universe and our place in it. In the end, the question of whether we could have detected 3I/ATLAS earlier serves as a reminder of how much there is still to learn about the universe. The discovery of this interstellar object is a groundbreaking achievement, but it is also a glimpse into a future where we may be able to detect more objects like it, unlocking new insights into the dynamics of space and the potential for life beyond our solar system. What if the arrival of 3I/ATLAS, the first known interstellar object to pass through our solar system, is not just a scientific anomaly, but a profound cosmic event that signals a deeper understanding of our place in the universe? What if this moment, seemingly simple in its occurrence, holds greater significance, pointing to the fact that we are on the edge of a much broader and more interconnected cosmic reality? The discovery of 3I/ATLAS forced us to reconsider our place in the universe. For millennia, humanity has looked up at the stars and wondered if we are alone, if life beyond Earth exists, or if the universe is simply a random arrangement of stars and planets. The detection of this object, coming from outside our solar system, challenges this view and invites us to think more expansively about the nature of the cosmos. Until 3I/ATLAS, we assumed that the objects we encountered within our solar system were primarily the products of our sun's gravity, born from the same cosmic processes that formed Earth, Mars, and the other planets. But 3I/ATLAS turned that assumption on its head. This object came from a different star system, from a place beyond our reach, beyond our current understanding, and yet it made its way into our solar system. The very fact that it exists suggests that our solar system is not an isolated island, but a small part of a much larger, interconnected universe. In many ways, 3I/ATLAS serves as a symbol of the vastness of space and the interconnectedness of the universe. The object's passage is not just a chance event, but a reminder that our solar system is part of a much greater cosmic network, one where objects, information, and possibly even life travel between stars, planets, and galaxies. 3I/ATLAS could be seen as a cosmic bridge, a physical manifestation of the relationships between different star systems, illustrating how material, energy, and information can travel across vast distances in ways we are only beginning to understand. But beyond its scientific significance, 3I/ATLAS also raises existential questions about humanity's future. What does it mean for us to live in a universe where interstellar objects are passing through, carrying with them the stories of distant stars? What does it mean for us to be the first to observe such an object, to be the first to recognize the existence of other star systems and other potentially intelligent beings? If 3I/ATLAS is a sign that other civilizations exist in the cosmos, then its passage could be a subtle reminder that we are not alone. It forces us to ask, if other civilizations have already mastered the art of interstellar travel, what does that mean for us? Are we just beginning our journey into the stars, or are we missing opportunities for contact, for communication, for understanding the broader cosmic landscape? In this light, the passage of 3I/ATLAS is more than just an astronomical event. It is a philosophical one. It is a reminder that our understanding of the universe is incomplete, and that there are forces, phenomena, and possibly civilizations out there that we are not yet capable of comprehending. What if 3I/ATLAS is not just an object but a clue, an invitation to reach beyond the boundaries of our solar system and explore the stars? Its arrival is a sign that the universe is full of surprises, unexpected visitors from distant places, carrying with them the potential to alter our understanding of life, technology, and the cosmos itself. And if this is true, what does it mean for our future as a species? If 3I/ATLAS is a product of an advanced civilization, then the object represents the possibility of interstellar communication, exploration, and cooperation. It reminds us that, as we look up at the stars, we might one day find that the universe is not as vast and empty as we once believed. Perhaps there are other civilizations, quietly waiting for us to join them in the great cosmic dance. Perhaps the future of humanity is not to remain isolated in our small corner of the galaxy, but to reach out, to explore, and to connect with the greater universe. The passage of 3I/ATLAS, then, is not just a cosmic curiosity. It is a turning point in the way we think about the universe and our place in it. It is a reminder that there is much more out there than we can imagine. The universe is a vast, interconnected web of stars, planets, and galaxies, and we are just beginning to understand the complexity of that web. The arrival of 3I/ATLAS opens up the possibility of new discoveries, new connections, and new ways of thinking about the cosmos. It reminds us that we are not just passive observers of the universe, but active participants in its unfolding story. As we continue to study 3I/ATLAS and other interstellar objects, we are likely to uncover more clues about the nature of the cosmos and our place within it. These discoveries could lead to a deeper understanding of the forces that govern the universe and the potential for life and intelligence elsewhere in the galaxy. We may one day look back at the passage of 3I/ATLAS as the moment when humanity took its first steps toward understanding the broader universe, and perhaps even making contact with other civilizations. In the end, the cosmic significance of 3I/ATLAS is not just about the object itself, but about what it represents: the vast, interconnected universe that stretches out before us, full of mysteries, possibilities, and discoveries waiting to be made. The arrival of 3IATLAS challenges us to think bigger, to look beyond our own solar system, and to consider the infinite possibilities that lie beyond the stars. What if 3IATLAS, the first known interstellar object to pass through our solar system, is not just a scientific curiosity, but a turning point in the history of humanity's exploration of the cosmos? What if its arrival marks the beginning of a new chapter in our journey? A chapter where we move beyond our solar system and begin to explore the vast expanses of interstellar space. What lies ahead for us as we stand on the edge of a new era of space exploration, guided by the lessons we've learned from the passage of 3IATLAS and the growing awareness of the infinite possibilities beyond our world? The discovery of 3IATLAS has sparked a profound shift in how we view the universe. For centuries, humanity has looked up at the stars, dreaming of reaching them, of exploring the unknown, of seeking out other civilizations and life forms. But until now, the idea of interstellar travel has seemed like a distant fantasy, something that might happen far in the future, if at all. Yet, the arrival of 3IATLAS has shifted that perception. It's no longer just a theoretical possibility, it's a tangible event, a reminder that the universe is full of unknowns, full of objects, phenomena, and possibilities that we are only beginning to understand. So, what comes next for humanity as we take this first step into the broader cosmos? What if the study of 3IATLAS and future interstellar objects is just the beginning of a journey that will take us to the stars, to distant exoplanets, and perhaps even to other civilizations? What if, in the near future, humanity develops the technologies to follow in 3IATLAS's wake, sending our own probes, missions, and spacecraft to explore the depths of interstellar space? The technological advancements required for interstellar exploration are immense. We are still at the early stages of developing the propulsion systems, energy sources, and spacecraft technologies needed to travel vast distances between stars. But the discovery of 3IATLAS has made the idea of interstellar travel feel more real, more within our reach. If an object from another star system could travel through our solar system, why can't we? What if, with the right technological breakthroughs, we could send probes to distant star systems, study their planets and stars, and perhaps even make contact with other intelligent civilizations? One of the biggest challenges we face is the vast distances between stars. Even with the fastest spacecraft we have today, it would take tens of thousands of years to reach the nearest star systems. The sheer scale of interstellar travel presents an immense obstacle, but it's not insurmountable. We've already made incredible progress in space exploration, and technologies like solar sails, nuclear propulsion, and even theoretical concepts like warp drives are being explored as potential means of traveling faster than the speed of light. While these technologies are still in their infancy, the fact that we are even discussing them shows how far humanity has come and how far we could go. What if the passage of 3IATLAS is a sign that we are on the cusp of a new era in human space exploration? What if, in the not-too-distant future, we look back at this moment as the beginning of our journey beyond the confines of our solar system? As we continue to study objects like 3IATLAS and develop new technologies, we might find that the dream of interstellar travel is not as far off as we once thought. One of the most exciting aspects of humanity's potential future in interstellar exploration is the possibility of discovering other life forms. 3IATLAS has already sparked a conversation about the potential for intelligent civilizations in other parts of the galaxy. If objects like 3IATLAS are indeed probes sent by other civilizations, it raises the tantalizing question: are we alone in the universe? The passage of 3IATLAS forces us to reconsider our place in the cosmos and opens up new possibilities for the discovery of life beyond Earth. As we develop the capabilities to explore the stars, we will need to rethink our understanding of life, intelligence, and the potential for other civilizations to exist in the galaxy. Could there be other forms of life, perhaps radically different from our own, living on distant planets? Could these civilizations be sending out probes like 3IATLAS to study the cosmos and communicate with us? The possibilities are endless, and the search for extraterrestrial life is no longer just a theoretical exercise. It is a real possibility, one that could shape the future of humanity. But the journey to the stars is not just about exploring other planets or finding other life forms. it is also about expanding our own understanding of the universe. As we continue to explore the cosmos, we will inevitably encounter new mysteries, new questions that challenge our current knowledge. What if the study of interstellar objects like 3IATLAS leads us to uncover new laws of physics, new materials, or new forces at play in the universe? What if our exploration of the stars leads us to discover things that fundamentally change our understanding of space, time, and reality itself? In many ways, the study of 3IATLAS and future interstellar objects is just the beginning. As we continue to push the boundaries of space exploration, we will unlock new knowledge, new technologies, and new possibilities. And with each new discovery, we move closer to understanding our place in the universe, and perhaps even to answering the most profound questions of all. Are we alone? And if not, what lies beyond the stars? The next steps in humanity's cosmic journey are unknown, but one thing is certain: the arrival of 3IATLAS is a sign of things to come. It's a reminder that the universe is vast, full of mysteries and possibilities, and that our journey as explorers of the stars has only just begun. We may have started with a single interstellar object, but where will we go from here? The universe is waiting, and the journey is ours to begin. What if the arrival of 3IATLAS marks the beginning of a new chapter in the story of human exploration? What if, years from now, we look back at this moment not just as a singular scientific discovery, but as the spark that ignited humanity's collective journey into the stars? Could 3IATLAS be the first step in a long and transformative era of space exploration, one that will shape the future of our species and our understanding of the cosmos? The discovery of 3IATLAS is, in many ways, a milestone, a singular event that stands as both a beginning and a symbol. As the first interstellar object ever detected, it opens up a new frontier for scientific exploration. We now know that objects from beyond our solar system are out there, traveling across the vast distances between the stars, silently passing through our cosmic neighborhood. The questions that arise from its passage about the nature of interstellar objects, the possibility of intelligent life, and the future of interstellar exploration are just the beginning of a much larger journey. What if, decades from now, humanity looks back on the discovery of 3IATLAS as a defining moment in our quest to reach the stars? At the time of its discovery, 3IATLAS seemed like a singular anomaly, a strange visitor from another star system that entered our solar system, sparked curiosity, and then disappeared. But as we continue to develop our spacefaring technologies and refine our ability to detect objects from distant star systems, we may come to see 3IATLAS as the first in a long line of interstellar visitors. Future interstellar objects, discovered with greater speed and precision, could provide us with even more clues about the universe and our place in it. The legacy of 3IATLAS lies not just in the information we have gathered from it, but in the paradigm shift it has sparked. For centuries, humanity's exploration of the cosmos has been confined to the boundaries of our solar system. We've sent probes to distant planets, landed on the moon, and even launched telescopes to peer into the depths of space. But 3IATLAS has reminded us that the universe is far larger and more interconnected than we ever imagined. It has shown us that the stars are not distant, isolated entities, but part of a vast cosmic network that links star systems across vast distances. Our solar system is not an island in space. It is part of a larger, dynamic, and interconnected cosmos that is teeming with possibilities. This realization opens up new avenues for exploration, discovery, and even cooperation with other intelligent civilizations, if they exist. Could 3IATLAS be a precursor to more interstellar encounters? Could the future of human space exploration involve traveling beyond the bounds of our solar system to distant star systems and interacting with civilizations or phenomena we've never before imagined? While the technology for interstellar travel is still in its infancy, the idea that we might one day travel to distant stars is no longer the stuff of science fiction. As we continue to study objects like 3IATLAS and develop the technologies needed for long-distance space travel, the possibility of exploring other star systems becomes more tangible with each passing year. What if 3IATLAS also represents the beginning of humanity's awakening to the realities of the larger universe? For centuries, we've looked to the stars with wonder, but now we've realized that the stars are not just points of light, they are part of a much broader, living universe. 3IATLAS has forced us to confront the idea that we are not the only sentient beings in the galaxy, and that other civilizations may have long since mastered the technologies we are only beginning to explore. It raises the possibility that we are not alone, and that the universe is full of secrets waiting to be uncovered. In many ways, the legacy of 3IATLAS is a philosophical one. It forces us to ask questions about our place in the cosmos, our role in the larger story of the universe, and the future of human civilization. What does it mean for us to exist on a planet that is just one small part of a much larger, interconnected cosmic system? What is our future in the galaxy? And how can we contribute to the greater story of interstellar exploration? These questions are not easy to answer, but they point to a larger truth. The discovery of 3IATLAS is not just an astronomical event, but a turning point in our collective understanding of the universe and our place within it. As we look to the future, the legacy of 3IATLAS will continue to inspire future generations of scientists, explorers, and thinkers. Its discovery is a reminder of the vastness of the universe, of how much there is to learn, and how little we truly know. The arrival of this interstellar object is just the beginning, a glimpse into the mysteries that await us as we venture deeper into the stars. In the years to come, as we continue to study 3IATLAS and the objects that follow in its wake, we may unlock new insights into the nature of the universe, the forces that govern space and time, and the potential for life beyond Earth. The study of interstellar objects may one day lead us to new discoveries about the origins of life, the dynamics of galaxies, and the possibilities of intelligent civilizations scattered throughout the cosmos. The legacy of 3IATLAS is not just a scientific one, it is a cultural and philosophical one. It reminds us that our journey is just beginning, that the cosmos is vast, mysterious, and filled with possibilities beyond our wildest dreams. It invites us to look up at the stars and wonder what lies beyond, to dream of a future where we are not limited to our own planet, but a part of a larger cosmic family. And perhaps, just as 3IATLAS quietly passed through our solar system, we too will one day journey beyond the confines of our own world, traveling to distant stars and encountering civilizations, phenomena, and knowledge that will change everything we thought we knew about the universe. The journey has just begun. The stars are waiting.